So this is the 13-3 trig ratios of any angle homework. Hopefully it's not a problem. I don't know. Now, it says draw the given angle, then find two angles that are coterminal. I'm actually going to do that first. I'm going to take away 360, and that's going to be 360 degrees. So there's one. I'm going to take away 360 degrees again, and I'm going to get 0 degrees, and there's two. There's my two coterminal angles. And you can obviously see that. Now, angles start on the positive x-axis. That's where angles start. All angles start if they're drawn in standard position on the positive x-axis. And then they rotate one to a terminal side. That was two rotations, I think. And then my third rotation. And any of those angles that I just talked about, the 360 or the, what is up with this thing? There we go. Doesn't matter. They all are in the same place. All right, 11 pi over 3. What you're going to do is you're going to do your replacement. You know that pi, when you're thinking about angles, is 180 degrees. If you're thinking about lengths, it's 3.14 and some crap. When you're talking about angles, pi is worth 180 degrees. And this would be 11. I'm just going old school by hand. 11 times 60, which is 660 degrees. So let's take away 360, and I'm going to get 300. All right. Take away 360 again, and I'm going to get negative 60. And that's actually the one I feel like drawing this time, because I'm just being lazy. But actually, it said draw the angle, didn't it? It didn't say draw the coterminal angle. It said draw the angle. But 660 is going to rotate 360, and then 300 more. It's going to stop right there with a little 60-degree reference angle. All right, moving forward. Find the reference angle theta prime, and PS drawing helps. So let's make this one right here a degree. It's going to end up being 3 pi over 4 is 135 degrees. And the reason we do reference angles again is because reference angles don't enable us, the original angle does not enable us to draw a right triangle. The reference angle is going to be the, I had a little brain fart there, forgive me. The reference angle is what it takes to get to the nearest x-axis. So theta prime here is going to be 45 degrees because, 180 minus 135 is 45. Now, it's not always about 180 minus. Sometimes it's 360 minus. Sometimes it's 270 minus. Sometimes it's 90 minus, but whatever. We got a 580. Let's do this one. This one's kind of a big angle. Negative 37 pi over 3. That'd be negative 37 times 180 over 3, which is negative 37 times what, 60? Yeah, I don't want to do that in my head. I thought I did. I don't want to. I got to conserve my brain power. So negative 37 times 60, negative 2220. Holy moly, that's a big angle. I don't want to draw that. So let's just add 360 a bunch of times. There we go, negative 60. Now, a negative 60-degree angle actually has, remember the original angle was like what? It went around and around and around and around. It was negative 220 degrees. But the reference angle, theta prime, is 60 degrees. The reference angles are always positive. Well, that's one thing. Reference angle is always positive. Moving forward, evaluate the functions without using a calculator using the reference angle theta prime. Draw the angle, find its reference angle, and use your knowledge from there to evaluate. Drawings must be shown, and these are done using 30, 60, 90, and 45, 45, 90 patterns. And don't forget the little acronym, all strippers take cash. I'm just going to do 10. All strippers take cash. A negative 150-degree angle is not that hard to draw. It's going to start here on the positive x-axis. It's going to rotate 90 and then 60 more. That's what the angle looks like. There's negative 150 degrees. The reference angle is going to be 180 minus 150, which is 30 degrees. And now it says use your knowledge of 30, 60, 90 and all that stuff. So I'm thinking about a 30, 60, 90. You should too. We got 1, 2, root 3. So opposite of 30 is a 1. Direction makes it negative. Adjacent to 30 is a root 3. Direction makes it negative. And hypotenuse, or hypotenuses, whatever it is, are always positive. Now, I mentioned ASTC. In this quadrant, only tangent and cotangent are positive. So I know, since I'm looking for sine, this must be a negative. That's in case I forget my signs. So from SOHCAHTOA, I know that I'm thinking about opposite over hypotenuse, and opposite of this 30 is a negative 1, and the hypotenuse is 2. Easy peasy, Japanesey. Shouldn't struggle. Not going to do any more of that. 16. A three-bladed windmill has a blade length of 50 meters. Find the arc length swept out by 3 rotations. So if I was to draw myself a three-bladed windmill, here's the base of the tower. Then let's just go ahead and put this in black. The angle between each blade would have to be 120 degrees. Now notice I want arc length. Arc length is denoted by the letter S, and S is r theta. The deal is, though, that theta is a radian. That's the big disclaimer. So I take my 120-degree angle and I multiply it by pi over 180. I memorized these a long time ago, so I don't actually do this anymore, but the zeros cancel. 12 over 18 is going to be 2 over 3. And I get 2 pi over 3. So another way of saying is that these things are 2 pi over 3 rads. Okay? The radius is going to be 50 meters. So my arc length is 50 times 2 pi over 3, which is simply 100 pi over 3. Now I want 3 rotations. 3 rotations. So I just 3 this thing, cancel. 100 pi meters. The area of a sector when a blade rotates 3/4 of a circle. So rotating 3/4 of a circle, if you just think about that, is like that. You just take 3/4 of 360, and I reckon you get 270 degrees. Seems right to me. Now, I have a formula for area. It's 1/2 r squared theta, same disclaimer, radian. So I take my 270 and I multiply it by pi over 180. And when I do such a thing, 0 zeros, degree symbols cancel too. 27 and 18 are both divisible by 9. I get 3 pi over 2. So moving forward, area is 1/2. A radius of 50. That quantity is squared. The angle of interest is 3 pi over 2. 50 squared is going to be 2,500. I got a 3 pi over 2. Let's see here. Half of 2,500 is 1,250. Still got that 3 pi over 2. I'm just showing you what I usually do in my head. 1,250 cut in half is going to be 625. So 625 times 3 pi. And that's going to be 1,875 pi square meters. That was 1875 Moving forward with my life, don't know about yours. Use the given point on the terminal side of an angle in standard position to evaluate the given trig functions of theta, and I expect to see drawings, and these are really, really simple as long as you're willing to draw and you know the Pythagorean theorem. The harder one's 18, so I'll do it. It says go right 5, and then go up root 11, or sorry, go down root 11. Like, what is root 11? It's a little over 3. You know, square root, maybe. It's about negative 0.32. Anyways, so I go down 1, 2, and a little bit more. So it'd be about right here. Now the truth is, that doesn't even matter. It doesn't. The angle would start here, rotate to the terminal side, and this would be what my angle looks like. Now, what matters is that I could draw a right triangle, and again, this was theta, this will be theta prime, and the dimensions of my imaginary triangle, 5 and negative root 11. Now I do little a squared plus b squared equals c squared. I plug some crap in. 5 squared plus root of 11 squared is c squared. 5 squared is 25. Root of 11 squared is 11 equals c squared. 25 and 11 makes 36. 36 is c squared. And c is 6. I want the cosecant and cotangent ratio. Cosecant is every single male's favorite trig ratio. She is a hoe. She is going to be 6 over negative root 11. We're going to go ahead and move that negative up top. We're going to clean up root of 11 on the denominator by multiplying by root of 11 over root of 11. We're going to get negative 6 root of 11 over 11. Next we have cotangent. Cotangent is the excited ratio. It says AO. So adjacent to theta is a 5, and opposite is that negative root of 11. So again, we're going to do the same cleanup process. We're going to multiply top and bottom by root 11 over root 11. And we're going to get negative 5 roots of 11 over 11. Done with that. If I went too fast, pause, right? I don't know why you'll expect me to be like one-on-one. It'd be wonderful. It doesn't work that way.